Hello viewers, friction question 5. Blocks of masses 3 kilograms and 7 kilograms are connected by a light string, which means that we can ignore the weight of the string. The coefficient of friction between the 3 kilogram block and the table surface is mu equals 0.3. Determine the acceleration of the blocks and the tension in the string. So I think I'll do this question as two separate videos. In this one we'll do just the acceleration and then we'll do the tension in the next one. Okay, so we have two blocks and we need to use Newton's second law here. So the mass times the acceleration is going to be the net force, and let's take, well, a pulley is what we have in the corner here. A pulley is an object which changes the direction of the forces. Let's take off the table to be the positive direction. So the mass times the acceleration is forces pulling off the table minus forces pulling back onto the table. So the mass of the whole system, both blocks in combination, are 10 kilograms equals what force is pulling acting to pull the 3 kilogram mass off the table. That would be the weight of the 7 kilogram object, 7 kilogram mass, minus force of pulling back on will be, the force pulling back would be the friction between the 3 kilogram mass and the table surface. So that'll be the force due to friction of the 3 kilogram mass. Note that there is no friction due to the 7 kilogram mass because it is not rubbing against anything. Also note here that the weight of the 3 kilogram mass is not acting to pull it on or off the table because it's pulling straight downwards, and in any case would be exactly cancelled out by the normal force from the table on that 3 kilogram mass. So we have 10 times the acceleration is that weight of that 7 kg. Weight is mass times gravity. Mass is 7 times 9.81 minus the force due to friction of that 3 kilogram mass. The force due to friction is going to be mu, the coefficient of friction, which we're given to be 0.3, multiplied by the normal force, which is, it's a 3 kilogram force multiplied by 9.81. There is no incline here. The surface of the table is perfectly horizontal, so the 3 kilogram mass is going to be moving perfectly horizontally. So 10 times the acceleration is 7 times 9.81 is 68.67, and 0.3 times 3 times 9.81 is 8.829. So therefore 10 times the acceleration is, if we calculate that bit, we get 59.8 is the net force, which is going to be pulling off the table. So the 7 kilogram mass will be accelerating downwards and the 3 kilogram mass will be accelerating to the right. So the acceleration is 59.8 divided by 10, and we get an acceleration of 5.98 meters per second squared. Thanks for watching. Over and out.